Hello, can you solve this interesting problem? A motorcyclist drove from one city to another. Half of the distance he drove with a speed of 100 km per hour. Another half of the distance he drove first with a speed of 90 km per hour for some time, and then 80 km per hour for the same time. Find the average speed of the motorcyclist on the total distance. Now you better pause the video to try to solve this problem by yourself, because from next I'm gonna give you the solution. Okay, let's get started. Some people make a common mistake in such problems. To find the average speed, they sum all the three speeds and divide it by 3. But this is not correct. So let me show you how to do it in correct way. First of all, let's make a drawing. So here we have 3 distances which motorcyclists drove with the different speeds. The first speed 100 km per hour, second speed 90 km per hour, and the third speed 80 km per hour. Also, it is given that the first distance equal to the half of the total distance, and the sum of second and third distance equal to the another half of the total distance. So we can write that S1 equal S total divided by 2, and we can write that S2 plus S3 equal S total divided by 2. It is also given that T2 equal T3. So let's write that T2 equal T3 and equal T23. So this is what we know from this problem. Now let's write the formula for calculating the average speed. So the average speed equal total distance divided by total time, which is which is spent to drove this total distance. So the total time we can write as a T1 plus T2 plus T3. But we know that T2 equal T3 and equal T23. So we can write, instead of T2 plus T3, we can just write 2T23. So all we need to do now is to find T1 and T23. First, let's find T1. T1 equal the first distance divided by first speed. We know the value for the first speed, it is this one, but we don't know the value for the first distance. But we know that first distance equal the S total divided by 2. So we can just write S total divided by 2V1. Now let's find the T23. To do that, let's look at this equation. So here, instead of S2, we can write V2 multiplied by T2. And instead of S3, we can write V3 multiplied by T3. But T2 and T3 are equal to T23. So it means that T2 and T3 we can just exchange with T23, and we'll get this equation. Now let's factor the left side, because we have a common T23 here and T23 here. Then we'll get this equation. So now let's multiply the both sides of this equation by 2 and divide by V2 plus V3. Then we'll get this equation. So now that we found T1 and T23, we can put these fractions to here, to this formula. Then we will get this expression. So we simply put, instead of T1, we put this fraction here. And instead of 2 multiplied by T23, we put this fraction here. From here, you can see that if we divide the numerator and denominator by S total, we can get rid of it. Then we'll get this expression. Now let's sum these two fractions. Then we'll get this expression. Now if we divide 1 by this fraction, we are gonna get this expression. Now we have finally derived the final formula to calculate the average speed for this problem. All we need to do now is to put the values of these speeds to this formula. Then we'll get this expression. Ideally, when you write the speeds, you also need to include the kilometer per hour for each speed. But I didn't include it because it would take too much space. So if we divide numerator by denominator, the answer will be about 92 km per hour. So this is the final answer. Thank you for watching. Subscribe for more videos.